So now we've explained the basics of combinations. Let's see how it's used. So combinations is used when you have selecting or choosing something where order is not significant. So the words I typically use is select or choose. So you're choosing a committee. So it doesn't matter who gets chosen first, who gets chosen second. You're selecting 5 tops. It doesn't matter which top you choose, you're taking them all. How I remember that is C is your choose. Whereas when you have P, remember that permutations where order is important, so that's place. Now for both of these, you can't have any repeats. So in question 7 here, we have, in how many ways can 4 books be selected from 7 different books? Now that's important, it's use the word selected, so that should note to you immediately we're working with combinations, but always check. So if I'm just selecting 4 books, does order matter? No, it doesn't really, does it? I'm just getting those 4 books. Doesn't matter which comes first or which comes fourth. Is there going to be repeats in this case? No, because once we've chosen the book, it's not on the shelf anymore. So no, I'm going to be working with combinations. So in this case, selecting or choosing 4 books from 7, it's just going to be 7C4. Just put into your calculator. So it's 35 different ways that you can select 4 books from 7 different books. So in question 8 here, we want to find out how many ways a committee of 3 women and 4 men can be chosen from 8 women and 7 men. So chosen should also just immediately say to you, it's going to be combinations, but just always check. Just have a think about it. If I'm choosing a committee of people, does it really matter whose name I say out first and whose name I say out third? It doesn't at all, does it? Because you're choosing a group of people. How you consider this, if there's 8 women, I'm going to be selecting 3 of them. But it doesn't really matter who gets selected where. Just 3 of them are getting chosen. And then out of 7 men, 4 of them are getting chosen. So then we kind of just work it out as in consider the women and the men. So out of the 8 women, 3 are chosen. Out of the 7 men, 4 are chosen. But it's going to be and between them because together they make that committee. So that's why you multiply them together. So that's just some calculator work, and it's 1,960 ways. And you can actually see in the diagram they are linked together in one committee, and that's why it's really important to use and multiply. What about something a little bit more difficult here? What is the number of ways when woman A refuses to serve on this committee if woman B is a member? So remember right at the start with factorials, I said when they say they're not together or they refuse to serve, what you need to do is all the selections minus the selections when they are together. That's the way to do these questions. So let's consider the number of ways that woman A and B are together first. So we're going to do all minus A and B together to give us this answer. We have this here. So with the men, it's exactly the same. So out of 7 men, I'm still choosing 4 men. The difference here is women. You can see here that A and B, we're considering that they are together. They've already taken up those spots. So those spots are gone, which means there's only 1 spot left. Now, because those women have already been selected, they're not in the pool of people to be chosen, are they? So there is 1, 2, 3, 4, 5, 6 women left for you to choose that remaining 1 spot. All right? A and B have already taken that spot, so there's only 1 spot left. A and B are already on the committee, so there's only 6 women left to choose from. So that's why, to make sure that A and B are together, it's going to be 6C1. So out of 6 women left, I choose the 1 place that's left over, multiplied by 7 men choosing 4, which is the same. And that gives me 210 ways. And to work out the number of ways when they refuse to be together is all minus that. It's just going to be this minus that, which is 1,750 ways. So what you can see here, what we've done is when people refuse to be together, 2 things can't be in the same group together, you always do all minus them actually being together, So the opposite of what the question says. And the important thing here is to recognize this step. So you just think 2 spots are taken, there's only 1 spot left. and how many women are there left to choose for that one spot. Yeah, so it's that simple. I think where people get confused is when you start thinking about arrangements and you think A and B, do I have to mix them? You don't need to think about that at all because you're only selecting people for a committee in this case. So in question 9 here, we have a family of 2 adults and 6 children, and let's just say they receive 4 free tickets to a show. Because it's a show, at least one adult must go to accompany the children. So how many different selections are possible? Now, a couple of keywords here. Selections, so I should note to you straight away, it's probably going to be combinations. So we think about it, well, how many children, which one's chosen first to go and second to go doesn't really matter. The point is they're going together. And there's not going to be any repeats, so it is combinations. The other notable word is at least one adult. So when it says at least one adult, it should signify to you to think straight away, all right, I'm going to be working with or. So it's going to be one adult or 2 adults because it's at least one adult out of 2. So that means I need to consider when there's 2 adults going and when there is 1 adult going. Now, when there's 2 adults going, because there's 4 tickets, then there's only place for 2 children out of the 6 children to go. Now, when there's 1 adult going, there'll be place enough for 3 children out of the 6 children to go. And because I'm saying it's or between them, so it's 2 adults or 1 adult, I'll add these together. So let's work out what each of these are. So out of 2 adults, I'm choosing 2. So that'll be 2C2. Now out of 6 children, I'm choosing 2 children. So that'll be 6C2. And that equals to 15. Here, I have 2 adults, I'm choosing 1, so 2C1. And out of 6 children, I'm choosing 3 children, so that's 6C3. And that just multiplies together to equal 40. Now, because it's 2 adults or 1 adult, so it could be this version or this version, I just added together 15 plus 40, and it's 55 different ways. So can you see here, because it says at least 1 adult, you should know straight away you got to work out the number of selections for 1 adult and then the number of selections for 2 adults as well and add them together. Let's have a look here at question 10. So this is going to be quite a difficult question. So if you do get confused, please don't be afraid to go back and have a look at this question. Here we want to find the number of different selections of 5 letters that can be made from the letters of the word syllabus. So it's going to be selections. All it is 5 different selections. So in this case, order doesn't matter. It doesn't matter if I have LL, SSB or SSLLB. It doesn't matter about the order. It's only selections. And the other thing is, because it's the word syllabus, we're going to have repeats here. So we have L and L is repeated, S and S is repeated. But Y, A, B, and U, there's no repetitions of those. So now you need to consider a couple of things. So 5 letters are being selected, okay? So it's 5 letters. There's going to be 3 different possibilities. So the first possibility that you can have is you choose all of the repetitions. So you're choosing repetitions, and that's repetition. So 2 alike, 2 alike, and there's only 1 different. So only that 1 different can make it different. The other option that you can have is if you just have that 2 of these are alike. So you have 2 alike, but 3 different. And then finally, you can have 5 different. And that's what we've done here with this table. So you can either have 2 alike, so LL, and 2 alike, and 1 different like that. Remember, order doesn't matter. So it doesn't matter which way L and S are. Or you can have 2 alike, but 3 different. So I can either choose L, the alike, or I can choose S as my 2 alike. And then finally, when there's 5 different ones. So can you see how there's these 3 different options here? And that's how we're going to get our selections. Let's consider this first option, where there's 2 alike, and 1 different. So if these are all alike, can you see how only what goes in here is going to make it any different? So only if we choose Y, A, B, or U is there going to be a difference there. So out of those 4, I can only choose 1. So that's why it's 4C1, which equals to 4. Now, let's consider this one. We already have LL, so don't consider that. Now, to make it different, I can choose Y, A, B, U, and S. Essentially, because the S's are the same, I can really only choose one S. Choosing the other S still makes it S. So really, I'm only selecting from S, Y, A, B, and U. So now that means from 5, I'm going to be selecting 3. So that's why it's 5C3. When it's S, so we get rid of S, I can only choose from L, Y, A, B, U. So that's why it's 5C3 here. Finally, when it's 5 different, Y, A, B, U can be chosen, but S, you can only really choose one of the S because the other S is the same, and L, only one of the L because the other L, if you choose it, will be the same as well. So you can only choose from L, S, Y, A, B, or U. So in this case, it'll be 6C5, which equals to 6. Now, at the very start, I said it could be any of these options. So it could be this, or that, or that, or that. So because it's this, or this, or this, or this, I add it all together, so 4 plus 10 plus 10 plus 6, to tell me there's actually 30 ways of selecting 5 letters from here. This is a difficult question, but just consider what we did here, which is the 3 different options, where you can choose 2 alike, and 1 different, 2 alike and 3 different, or we have 5 different. And then we've just worked it out here, which I think is not as difficult as just that first concept.